Dear students, very good morning. Today we will discuss the chemical properties of organohalogen compounds. Let us take chemical properties of alkyl halides. Alkyl halides exhibit nucleophilic substitution reactions, elimination reactions, and also they react with metals and form organometallic compounds. In case of nucleophilic substitution reactions, nucleophile attacks on the reaction center and replace the halogen from the organohalogen compounds, and there is a formation of nucleophile substituted product. In this reaction, the halogen will be replaced by the nucleophile or substituted by the nucleophile. In the case of elimination reactions, the negatively charged chemical species abstract proton, and also finally there is elimination of halogen from the reaction center, and there is a formation of unsaturated compound, that is alkane. Then what is the difference between nucleophile and base? If you observe, the negatively charged chemical species attacks on the reaction center in the case of nucleophilic substitution reaction. It means if the chemical species attacks on the reaction center, that can be called as nucleophile. If the same chemical species abstract proton, then it can be considered as a base. And also they react with metals and they form organometallic compounds. Here the alkyl halide react with magnesium in dry ether and they form alkyl magnesium halide. It is known as Grignard reagent. And also it reacts with the sodium in dry ether and form symmetric alkanes. It is known as Wurtz reaction. This is about chemical properties of alkyl halides. Nucleophilic substitution reactions are classified into unimolecular nucleophilic substitution reaction, that is SN1, bimolecular nucleophilic substitution reaction, that is SN2, intra or internal molecular nucleophilic substitution reaction, that is SNI. If you take SN1, in this reaction we have two steps. In first step there is a leaving of halogen from the reaction center and there is a formation of carbocation intermediate. The first step is the slowest step and the number of molecules which are involved in the slowest step is 1. That's why the molecularity of the reaction is 1. And in second step, the nucleophile attacks on the planar carbocation from front side and also back side. And there is a formation of two stereoisomers which are non-superimposable mirror images. Okay, these are called as enantiomers. So in SN1 case, you will get mixture of enantiomers. You will get racemic mixture. In the case of SN2, there is a attacking of nucleophile on the reaction center and there is a leaving of halogen. In this case, attacking and leaving of halogen, attacking of nucleophile, leaving of halogen takes place simultaneously. The mechanism is concerted mechanism. It takes place in single step. Here, there is a formation of pentacoordinate transition state. This pentacoordinate transition state decomposes into nucleophile substituted product and halogen. Here, since the nucleophile attacks the reaction center from the back side, here there is an inversion of reaction center. This inversion is also called as Walden inversion. In case of intramolecular nucleophilic substitution reaction, okay, this reaction is not exhibited by alkyl halide. This reaction is exhibited by chlorosulfonyl esters. If you take alcohols, when you react with the thionyl chloride, you will get chlorosulfonate esters. This chlorosulfonate ester decomposes to chlorine substituted or alkyl chlorides and also SO2. In this mechanism, the nucleophile, that is chlorine, attacks on the reaction center from front side. That's why here there is a retention of configuration. In SN1, there is a retention and inversion of configuration. In SN2, there is an inversion of configuration. In SNI, there is a retention of configuration. Elimination reactions of alkyl halides are classified into unimolecular elimination reaction, that is E1, bimolecular elimination reaction, that is E2, unimolecular conjugate base elimination reaction, that is E1CV. Let us check the mechanism of E1. The mechanism of E1 is similar to the mechanism of SN1. It takes place in two steps. In first step, there is an elimination of leaving group from the reaction center and there is a formation of carbocation intermediate. After that, there is an abstraction of the proton by the base and there is a formation of alkene. The first step is the slowest step. In this step, there is an involvement of alkyl halide, means there is an involvement of one molecule, so that molecularity of the reaction is 1. If you take the mechanism of E2, this one is similar to the mechanism of SN2. In this mechanism, you can find only one step. It's a concerted mechanism. In this mechanism, there is abstraction of proton by the base and there is a cleavage of bond between CH. At the same time, there is a cleavage of bond between carbon and halogen. The cleavage of CX bond and the CH bond take place simultaneously and there is a formation of alkene. If you take E1CB, here first there is an abstraction of proton by the base and there is a formation of carbanion. This is the conjugate base to the alkyl halide. And in second step, there is an elimination of halogen from the reaction center and there is a formation of alkene. The first step is a fast one. The second step is a slowest step. In second step, there is an involvement of conjugate base only. So the rate of the reaction depends only on the conjugate base concentration only. That's why the molecularity of the reaction is 1. If you observe the mechanism of E1, E2 and E1CB, in E1, first there is a cleavage of bond between carbon and halogen. In E2, there is a cleavage of bond between carbon and halogen and carbon and hydrogen simultaneously. In E1CB, there is a cleavage of bond between carbon and hydrogen. The chemical properties of aryl halides. Aryl halides exhibit nucleophilic substitution reactions, electrophilic substitution reactions, and also they react with metals. Based on mechanism, nucleophilic substitution reactions of aryl halides are classified into addition-elimination and also benzene. If you take addition-elimination mechanism, first there is a addition of nucleophile to the reaction center. This is the addition of nucleophile to the reaction center. After that, there is an elimination of halogen from the reaction center. This type of mechanism is exhibited by the aryl halides containing electron withdrawing groups such as nitro groups at para position or ortho position. In this mechanism, the first step is the slowest step and the second step is a fast step. The next mechanism is benzene mechanism. This mechanism will be followed by the aryl halides when there is a strong base like amides or alkoxides. In presence of strong bases, there is a abstraction of the proton on the benzene ring, and also there is a elimination of halogen. This leads to formation of benzene. This one is the intermediate. This intermediate contains triple bond. After that, there is an addition of BH to the triple bond, and there is a formation of substituted benzene. Here the benzene, if you take the benzene molecule, this is nothing but benzene having one triple bond. We know that aryl halides exhibit electrophilic substitution reactions. Halogen, if you take a halogen is a ring deactivating group, but they direct the electrophile to the ortho and para position of the benzene ring. So in this case, when you add electrophile, when you add electrophile to the benzene ring, there is a electrophilic substitution at ortho position and para position. And also they react with metals and form organohalogen compounds. If you react aryl halide with magnesium dissolved in dry ether, there is a formation of aryl magnesium halide. And also they react with sodium. They form CC bond between two aryl groups. This reaction is called as Fittig reaction. And also they react with alkyl halide in presence of sodium dissolved in dry ether, and there is a formation of CC bond between aryl group and alkyl group. Means in the case of Wurtz reaction, there is a CC bond formation between two alkyl groups. In the case of Fittig reaction, there is a CC bond formation between two aryl groups. In the case of Wurtz-Fittig reaction, there is a CC bond formation between alkyl group and aryl group.